right, welcome everybody. Welcome to the sixth edition of IoT World Days with major focus on manufacturing. My name is Lucian Fogoros. I'm the co-founder of IoT World. And on behalf of my team, our sponsors, and the speakers, thank you all for joining. Thank you to the 7,000 plus folks from 125 countries for joining us. A couple of quick reminders, a couple of new things. Yes, we do have a new platform since the last version. Thank you to Big Marker for this awesome platform. So feel free to leverage it. Feel free to ask the question. All 40 plus speakers are live. And the other thing that at the end of each session, you'll see an email with a certificate of completion. So that is yours. So you could use that for continuous education and everything else. Without further ado, I'd like to introduce the moderator for the session. Kathy, the floor is yours.
Thank you, Lucian. Hello and welcome, everyone. I'm Kathy Cahalan from Bennett AI, and I'm excited to be moderating this first panel discussion of the day, AI-powered IIoT applications for predictive maintenance of machines. I'm joined by industry experts from Pollen Technology, Aviva, Schneider Electric, and Harman Digital Transformation Solutions. We have a very packed session as we explore the groundbreaking realm of AI-driven IoT applications. We'll cover topics from AI and IoT technologies. We'll discover how predictive maintenance analytics and machine learning algorithms can preemptively identify potential equipment failures, optimize machine or maintenance schedules, and minimize downtime. So before I start, I'd like to take a moment to ensure that everyone's acquainted with the webinar tool and to go over just a couple of housekeeping items. So if first you can look around, and over on the right side, you should see the chat button, this chat function. So if you can click on that, I'd love to have everyone just sort of enter where you're located. And we're really happy to have you join us. So Algeria, Houston. Good morning, Simon. Hi, Jane. And Chicago, Germany, France, India. Wow, quite dynamic group. This is wonderful. So now the next thing I'd like to do is I'd like you to note the function key right beside the chat, which is the Q&A. We're going to have you enter all your questions into the question section. We're going to use this instead of the chat feature. That makes it easier for us to actually see your questions and to be able to answer them. Now, in our allotted time for questions at the end of the session, we may not get to everyone's, but I've been assured by the IIO World team that there will be follow-up. So please just ask away. I also want to make you aware of a couple of upcoming IoT World events that are coming up at the beginning of the year. So mark your calendar. March 14th is IoT World Energy Day. And May 22nd is IIoT World Manufacturing Day. And just a reminder, this session runs for 59 minutes, so leaving just enough time to get you to your next session, which is Accelerating Innovation and Agility in Manufacturing with IIoT and Machine Learning. So on behalf of myself, the panelists, and IoT World, I want to express our sincere gratitude to our sponsors for their crucial support in making this virtual conference possible. And additionally, a special thanks to Pollen Technology and Harman Digital Transformation Solutions, our session sponsors. Your contributions greatly appreciated, gentlemen. So now I'd like to introduce our esteemed panel, and I'm going to ask them to tell us a little bit about themselves and their companies. I'm going to go in order of who I see on the screen. So Jim, if I could have you start. Jim is the Global Head of AI and Advanced Analytics at Aviva.
Sure. Thanks, Catherine. Like you said, I'm head of AI and advanced analytics at Aviva across its different businesses. Aviva's been around for over 50 years, and it's a global leader in industrial software with offices in over 40 countries. It's also a subsidiary of Schneider Electric. Its businesses include engineering design, operations control, maintenance, value chain optimization, and data. We actually acquired OSIsoft Pi a couple of years ago, and we're now also a cloud data platform company as well. So personally, I've been doing AI for a long time, since the early 1990s, starting with expert systems, and predictive maintenance, predictive analytics for over 20 years, as well as many other flavors of AI. I was founder and managing officer of InStep Software which was a leading global provider of enterprise big data and predictive maintenance software. And we were acquired by Schneider Electric in 2014, which is how I joined the Schneider and Aviva family. I started my career a long time ago as a nuclear engineer and was also an officer in the nuclear Navy in the US, where I had a top secret clearance. And that's where I originally got a lot of hands-on operational experience dealing with things like control systems, maintenance practices, data, and analytics. So I'm looking forward to this discussion on predictive maintenance and answering any questions. Thank you.
Great. Thank you. Alex, if you could go. Alex is the CEO at Pollen Technology.
Yes, thank you. I'm represent Pollen Technology, co-founder and CEO. We are a fabless semiconductor company focused on new generation analog neuromorphic chip technology. So our idea is to deliver opportunity for data processing on top of the sensor, various sensors like microphones, accelerometer, biosensor, and etc. And we use our own proprietary platform, which is completely analog, so no digital computation. And it works close by efficiency to biological system. And one of biggest application is predictive maintenance sector for pre-processed data from vibration and accelerometer. My background is solid state physics, so that is why I'm focused on this project 5 years ago, but the last 25 years I'm running as a serial entrepreneur in various deep tech companies as a co-founder and CEO. So that is not my first startup, but I hope also will be successful. And
Great.
I'm happy to introduce our technology.
Great. Welcome. So next on my screen is Vanyak. Can you please introduce yourself? Vanyak is the Senior Director of Harman Digital Transformation Solutions.
Yeah, thanks, Kathy. And it's really exciting show here. And I hope all the world participants are listening me through Harman products, because we are the manufacturers of JBL, Harman Kardon, and those kind of the products. For personally me, I'm working with Harman as a SME in Industry 4.0, mainly with a mission of how we can empower the shop floor people to use the latest technologies rather than restricting the technologies in the IT world. And in that context, basically, we are taking an advantage of AI and IoT platforms to make it available for the end users to use them in their day-to-day life. And the advantage, we being the manufacturing company, so we can walk the talk very easily. So our own premises are the premises where we are first testing out all efficiency gain with the help of the power of the AI. And now our next mission is with the help of our IoT platform, which is IoT in a box, which is a no-code platform. I will not call it as a low-code as well. But now with the help of that platform and the magic of AI, our next mission is like we can empower shop floor people to converse with the machine. So all the AI insights will be available in the form of Gen AI on different devices, whether it could be their mobile phones or it could be their virtual glasses. Because we have been acquired by Samsung a few years back, so we have an advantage of getting all the latest technologies to deliver the benefits on the shop floor, whether it is HMI screens or whether it is virtual technologies. So happy to be here, and I will try to give my experiences in this forum, and then basically later on you all can connect me to understand what we are working. But one key message I would like to give on behalf of the Harman, like we can connect the factories. It's too aggressive to say, but I can say like all your OT assets we can connect in few minutes by discovering them on their own with the help of our platform. So that's the kind of mission we have taken, and we have fulfilled that mission in our own factories. So happy to be here. Great. And would love to answer your questions.
Well, welcome. So Jürgen, you're next. Jürgen is the head of AI New Value Streams at Schneider Electric.
Thanks, Catherine, and hello, everyone. So yeah, my name is Jürgen Weichenberger. I'm part of Schneider Digital and also part of the Schneider Digital AI Hub, where I'm leading the New Value Streams business, or as we like to call it now, the direct customer business, meaning simple terms, customers have challenges. They're coming to us and asking, can you help us with it? That doesn't mean that we necessarily need to have a direct product to just say, here's a product, install it, thank you very much, job done. Usually it's exactly the other way around. We don't have a direct answer, and we need to look into all the assets. We at Schneider have, Jim already told us, Aviva is one of them, but we have a couple of others to play with, and finding, let's say, creative solutions to very complex problems. Predictive maintenance is a recurring theme for us. Many customers asking, how can I keep the ball rolling? So we often task to find solutions for that, expanding on various elements on it to make things work. For me personally, I'm in the AI space also. Like I said, call me a dinosaur. Back to 1995 when I started in the field of then what's called applied computer science, cybernetics, and bioinformatics. So slight different track to get into it. But let's say the industry caught me very quickly, and since ever then, it keeps me really excited. And the last 18 months in Schneider were super interesting. The previous nearly 8 years in Accenture, where I was running industrial analytics, was similarly super interesting because it gives me a wide picture of different customers and what drives the industry, what are latest industry trends you need to work on, and how you bring this back into solutions. So the key thing is when there's a lot of tech out there, but all the tech in the world doesn't solve problems. It's the people at the end of the day who translate technology into solutions for problems or challenges. And this is still something we're really trying to emphasize. There is not the magic thing there. It needs still people who turn technology into magic. And that's good for the time being. And that's also where we really try to expand on in Schneider.
Great. Well, welcome. So we're centering our discussion around three central themes. The first is the foundation of IIoT and predictive maintenance. We'll follow that with advancing predictive maintenance strategies and wrap up with user-centric approaches in IoT and future trends. So to begin, I want to borrow a quote from an article that I read from Aviva. And it stated that predictive maintenance approaches employ near real-time equipment and process data to predict failure. Predictive maintenance combines multiple data sources with analytics to predict failure at a higher degree of confidence and low false positives. So at this point, I'd like to invite Jim from Aviva to provide us an overview of the shift from reactive to predictive to risk-based maintenance.
Great. Thanks, Catherine. What you see on the slide here is a really high-level overview of predictive and prescriptive analytics. Prescriptive often goes hand in hand with predictive. So like Catherine said, predictive provides early warning detection of problems. And this could be days, weeks, or even months ahead of a SCADA or control system alarm or alert. And this gives you the time to take action to fix the problem and take corrective action so it doesn't become a major issue. In the upper right corner there, ARC did a study where they found that 82% of all industrial asset failures are random. They're not time-based. And it's those 82% of random failures that predictive analytics focuses on. And so if you look at the pyramid at the bottom there, reactive maintenance is run to failure. That's for low-value assets where you have plenty of assets on the shelf and you can just swap them out and it's not critical to your operations. That's still a valid maintenance strategy. Then there's preventative maintenance. This is the calendar-based maintenance where you're going to change the filter or lube the bearings on a calendar basis, once a month, once whatever period of time, whether they need it or not. You might be over-maintaining, you might be under-maintaining, you don't know. Then there's condition-based maintenance. This moves into more the calculation realm. You know, you're looking for if this pressure drops below a certain amount or the temperature gets too high, or maybe multiple things at the same time, you're going to trigger an alert. Somebody's going to look at it. And that's still a very valid maintenance strategy. The problem is you don't know what all the alerts are. You don't know what all those permutations are. And that's where predictive comes in. That enters the AI realm of maintenance. And this basically, you're building models and it uses data to create that digital twin or digital signature of the asset or the process. and you don't know what you don't know, and it will definitely tell you that. And so this is what predictive maintenance is, what this session is going to focus on. Now, beyond predictive maintenance is risk-based maintenance. And this is where you take it beyond, where you do things like, what's the remaining useful life of the asset, using forecasting, using deep learning. Can I make it to the next planned maintenance outage? Possibly linking in simulation for things like predictive asset optimization, where you're looking at what's the optimal time to perform the maintenance. Should I shut down now and fix it and save all the gain the efficiencies, or should I wait until the next planned outage and then shut down and do it? What's the trade-off there? What's the cost and efficiency trade-off? Or what can I do operationally different to improve maintenance, and what can I do maintenance different to improve operations? So it really breaks down the barrier between O&M. But the first step, and a real low-hanging fruit, if you have the data, start with predictive maintenance, and you can get very, very quick value from the data that you already have. Thanks.
Great. Thank you, Jim. So I'd like to open the discussion by asking Alex and Jim a couple questions around the importance of on-sensor data processing and data quality. So Alex, can you explain to us why on-sensor data processing is crucial for IIoT?
Yes, I just follow the Jim statement that data, it's for us, for AI model, it's important, relevant data, what we extract from raw data coming from sensor. And many of sensors, especially like accelerometer or piezo, they generate a lot of noise. 99% of this data, it's just a garbage. And if we transfer all these raw data to our cloud-based or extract information, it's overload of our network, it's consume too much power, and finally create this predictive maintenance strategy too expensive for many sectors. And very important solution, it's shift pre-processing with economically and power viable budget on top of the sensor, and only transfer relevant information for AI analytics. That reduced dramatically the total cost of ownership of predictive maintenance solution, and can expand market, because not only extremely valued assets and devices can be monitoring this way, but a lot of others, which is also important, but requires a lower cost. And key for cost reduction is on sensor data pre-processing and extraction of important information, and then use upper level predictive maintenance system only for analytics of this important data. That is how our biological system works.
Great, thank you. So Jim, can we expand on the data part of it, and let's talk about how we can help manufacturers ensure that the data quality is there for use with AI prediction models?
Sure. Yeah, like we've been saying, data is the lifeblood of AI, garbage in, garbage out. And what you want to avoid are false positives and false negatives, where you're missing events, or it's telling you have a problem when you really don't. You want to minimize that. And obviously, false negatives are the worst. You want the system to be useful. So you got to be able to detect quality as part of an overall data governance practice. So you can do things like flatline detection. This could be done through calculations. This could be done through AI. If a sensor dies, it's no longer transmitting anything. It needs to be detected very, very quickly. And these are some of the first things and the low-hanging fruit that you find when you put in a predictive maintenance solution are your bad sensors, because you need to know, as part of your IIoT and your digital twin, you need to know when these things are not working. But also outlier detection. When you're building a model and you have, say, temperature, pressure, flow rate, vibrations, whatever you might have in the model, they're statistically correlated. And when you're training the model on data, you can use AI to detect outliers that don't make sense. And it can scrub the data for you automatically using machine learning and deep learning. And then you can have a subject matter expert, somebody take a quick look and validate it. But you can do a lot of that scrubbing yourself or automatically using AI. And then there's when you're running the system, what if a sensor dies? It's going to throw all kind of bad alerts. Well, you can use techniques like, and a lot of the predictive maintenance or some of the predictive maintenance systems have a thing called adaptive fidelity. So if a sensor dies, it'll automatically remap the model. So say you have 10 sensors in your model and your outlet pressure sensor dies. It'll detect this and automatically rebuild the model instantly, so that it's running on 9 sensors instead of 10. So adaptive fidelity. And then, of course, visualization is still important for subject matter experts. I knew there was a problem last June. I'm going to take a quick look. I need the tools to look at my data, XY plots. I need to look at glyphs. I want to look at, spreadsheet kind of matrix, however I like to look at it, and quickly identify where the problem is and exclude it as well. So a lot of ways to implement data governance and quality control, such as using AI. And these are just typical ways you can ensure your data is good by use of a PDM system.
Great, thanks. So Alex, just going back to on-sensor data processing and how critical it is for IoT, what obstacles do you see hinder this, and what can we do about that?
Yeah, it's a well-known concept to shift pre-processing directly on sensor level. And the major barrier here is the power consumption, because the whole industry try going for wireless sensor node, which is much more cheaper in total cost of ownership and installation. And if you have a wireless system, the battery lifetime, it's a crucial resources. And power consumption for pre-processing, it's a major obstacles. In some cases, like for example, for smart tire, where you completely know way to change battery during the life cycle, that is the major showstopper. In some application, it's not physically barrier, but increase the cost of operation if you need to replace battery every couple weeks. So we think that is the most fundamental problem, because generally it's well known what to do. We have a lot of techniques, starting from simple fast Fourier transformation and going to more sophisticated algorithms and neural net data processing. But all of this, it's heavy computational, a lot of computing resources required, processing activity, and power consumption still the barrier.
Okay. So Vinyak, this question's for you. You shared with me the results of a survey conducted by McKinsey and Cisco that 60% of IoT implementation ends up at the point of care level, even for the uses of predictive maintenance or overall equipment effectiveness calculations. So given this, where are the typical roadblocks and what steps should be taken to maximize the benefits of AI and IoT for both the shop floor workers and the boardroom decision makers?
You're on mute.
You're on mute.
Yeah, I'm audible. Yeah. So Kathy, it's a very nice question, and fortunately or unfortunately, rather, I was the witness of some of the surveys what McKinsey and Cisco did. Yes, there are roadblocks and reasons for why IoT projects or the Industry 4.0 projects are not going to the higher level and they are ending their life at the POCs or the point solutions level. In fact, today's topic, the preventive maintenance, and there we have added the IoT. I would say we have to improve our vision in terms of the broader way. I would say industry fabric level we have to think, because when we call it about the preventive maintenance, if I contextualize back to the topic, then just IoT data, is it good enough to predict the preventive maintenance? Yes, up to certain level it can, because the way Jim and Alex talked about the multiple sensor data. But there are machines who are showing the performing results in the correct manner. But the overall product which has been manufactured by the process line might be having some challenges. So that another aspect is also important. Like, are there any misbehavior by the machines which are happening at the process level, when the end product is getting manufactured. So the roadblocks perspective, that is the another area, like whether AI needs some other data sources, like whether it is coming from your process level data capturing, or whether it is coming from your manufacturing planning perspective, or any other analytical insights from the other sources. And then basically the AI can really apply its own strength to find out meaningful insights. Of course, like IoT data or the telemetry data is good enough to get some basic insights. But what we have seen, there should be some more sources like stitched together, and we are calling it as now the industry fabric. So if at all you create that fabric in a correct manner, I think then the more insights or meaningful insights will come across. And the roadblocks perspective, I would say the roadblocks usually start from the planning itself, because the $1 million questions remains unanswered multiple times. Who will own the initiatives of Industry 4.0? Whether it is an IT team, whether it is an OT team, whether it is analytics, or whether it is any other team who is taking care of the business operations. And that first block, if we at all we cross by taking the vision from point solution level objectives to the bigger objectives, then I think the majority of the roadblocks will automatically be released. So that is the first planning level insights. If we apply the thoughts correctly, then automatically the road gets clear for the further implementation. And the second is like we have, at least in my career, I have seen at least 8 or 10 major programs where we start with the point solutions. Like we would like to get operational efficiency, we would like to get the predictive maintenance. But in my opinion, like if we achieve that up to the good extent, then the big question comes in front of us, like how to scale it further. So that is another roadblock basically usually people come across. And that's the reason, in fact, while planning phase, we have to create that complete organization level data fabric definition with all the sources by taking into the considerations. And the first milestone, in my opinion, should be the connected factory. So rather, I can say like the factory architecture. So if at all these teams come together and create the factory architecture properly, and then they start talking in the language of business KPIs. Of course, the preventive maintenance is the KPI, one of the good KPIs, but it is the technical KPIs. If we talk about the business KPI, like if at all preventive maintenance doesn't happen correctly or doesn't visualize correctly, how it is going to impact on the business KPIs. So if we start from right to left, then I think the preventive maintenance KPI will become the implicit achievement of the overall progress. So that is on the planning front. And on the implementation part, in my opinion, I have seen some of the failures post implementation where they have invited us to do the root cause analysis. So we have seen like every technical team is working in their own silos. And then basically it becomes the four blind man story to visualize the elephant. And then basically the program takes the another road to move towards the failure. So that is another thing we have to take care. And we always insist like there is a model of the think tank should be implemented. So there should be a proper responsibility matrix to be created to get an advantage. And then if we have all these basics things in place, then if you look at the benefits of the AI, because AI will get more than the telemetry data, and then basically the more powerful models can be designed, and then you will get a business KPI level insights where preventive maintenance will be the implicit KPI from that. So
Okay.
these are the food planning level roadblocks which definitely one should avoid.
All right, thank you. For time, we've got to move along a little quicker. We've got a lot of questions we still want to get through and get some good discussion points out for the audience. I want to just quickly jump to data biases in predictive models. So Jim, can you explain how the data biases affect predictive models and what are some of the ways we can eliminate it? You're on mute.
Somebody must have muted. Okay. Yeah, absolutely. So first, you really need to define what data bias is. In this case, it's not biased against humans. It's actually not properly representing the intended process or asset operations from a predictive maintenance perspective. So it includes things like garbage data that we talked about before. You need to identify and remove that. That can certainly impact or adversely impact the model and bias it incorrectly. But probably the biggest thing that affects data bias is missing data or lack of data, because that can cause false positives. You haven't been in this temperature condition before, or you haven't experienced this transient before, and now it's going to detect it as an anomaly and say you have a problem. So it's simply lack of data in the model that can cause false positives. And there's a number of ways to deal with that. One of the newer ways that we've dealt with it is through simulation. By combining predictive analytics with simulation, you can backfill. One, you can use pseudo sensors from simulation as extra sensors, but you can also backfill data through simulated data. Now, that's not going to be as good as the raw data coming from the asset, because that's the most accurate in terms of a digital twin and a representation of the asset operations, but it can get you a long way there, and it can really help. Another way is through templatized models, where you reuse data from one model to another. On large assets, expensive assets, not the best way to do it, because you can still get false positives, and it's usually, we found it's about 70% accurate, but it is a way to deal with missing data. But again, the best is from the data from the actual machine. So really, the way people do it operationally is, one, they wait until they generate enough data on that asset, which is good and bad. It may take you up to a year, depending on if it's affected by weather conditions and seasonal temperatures and so forth. Or you can use the PDM system to detect and add data as you go. It'll detect you have a false positive, and if you have somebody monitoring it, you just say, oh, I need to add data, and I'll add it. Or you can use simulation to backfill and train. So these are some of the primary methods of reducing data bias with predictive maintenance.
Great. Thanks, Jim. So now we're going to move on to the topic of advancing predictive maintenance strategies, and we're going to bring Jürgen into the conversation. So Jürgen, this question is for you. How is predictive maintenance shifting from a pure maintenance prediction to the optimization of remaining asset lifetime?
So that's a great question in the first instance, because we spoke about how we predict failures and then how we can take correct actions. But many of my customers asking now, okay, it's good to know when something breaks, but what I really want to do is, how can I make things run longer? Because you can imagine a lot of these machines are costly. So it's not just a dollar or two. So we are speaking here in scenarios of hundreds of millions of dollars. And so there's a real big shift to say, okay, I know when something goes wrong, that's cool, but how can I preemptively put an operational strategy out there which allows me to run longer, where I can literally continuously see, I'm doing X, Y, Z. What is the impact on my remaining asset lifetime? Is this good? Is it bad? But it also brings you in a position when you have an economic situation where you say, the price for my product is super high, or is in super high demand. I want to push. I want to get as much product out as I can. And hereby, then you say, yeah, it looks always very lucrative. Oh, yeah, as every unit I produce gives me added revenues. But there comes also the point where literally the added revenue gets outweighed by the cost of maintenance, or even by the cost of losing the asset. So it starts adding a whole set of new questions of, how can I alter how I operate by protecting the asset, run as long as possible, while I can also integrate now economic factors in my operational strategy. And so this is where we're saying, lots of customers now saying, this is where we have to add on to the classic VDM solutions to see how this helps me to get smarter and more effective.
All right, thank you. So with the many advantages of predictive maintenance, companies need to think about scaling this. So Jim, I'd like to ask you, what are some of the challenges of and strategies for implementing a PDM at the enterprise level, and how do we scale it for maximum benefit?
Yeah, that's a big topic, because enterprise predictive maintenance is more than just an AI algorithm that you prove out at one or two sites. You're moving to a global data platform. Sometimes this is replicated data, or this could be a cloud-based data platform, but it needs to be easily accessible. And you got to deal with things like regional data domicile requirements, say in Europe or China or different areas of the world, because you can't just deal with data the same way throughout the world if it is truly a global or a multi-continent type deployment, or even reasonably large scale. And so another thing is all this data needs to be properly time aligned. Typically, you go off UTC, universal time, but you got to make sure that when you're building models that all the sensors time align based on your historian strategy or your data lake strategy. Another aspect are the tools and processes. You can't just have a data science algorithm. You need things like case management, alarm management, communication methods. You need to be able to roll out the models, maybe using templates, templatized rollout. So you can standardize the rollout, standardize the building of the models, but also standardize the tuning of the models as you move forward, because things change. And then how do you capture lessons learned and incorporate that toward process improvement? One of the things we do at Aviva is we have an AI Center of Excellence that helps larger companies get started by shadow monitoring at the enterprise level to help train them. Because one of the things that has nothing to do with technology, but it's that quote unquote big brother watching syndrome. You could have a central monitoring center, and then you call up a local site and say, hey, you got a problem with this compressor or this pump, and they take offense. And so there's techniques to deal with that. And so that could be the difference between success or failure of an enterprise level PDM rollout. And so, in the interest of time, I'll stop there, but these are just some of the issues that an enterprise PDM system must solve. Part of it's through technology, part of it's through software capabilities, and part of it's through processes in the implementation of the enterprise predictive maintenance system.
Great. So Jürgen, a few minutes ago, you talked about the shift from predictive maintenance to optimization of the remaining asset lifetime. Can we expand on that? And can you tell us how predictive maintenance can contribute to capital expenditure protection?
Absolutely. So, as I said, assets are expensive. Not everything, but when you look into big main components, it is critical to understand what the cost of replacement is and how you want to avoid it. And I can give you a very practical examples. In the world of desalination, you're using RO membranes. So it's the core part of purifying water. And the manufacturers usually give you instructions on how to handle them and how to keep them alive. This has nothing to do with PDM at this point in time. It's a pure instruction to say, if you do this, we expect you to get a certain life. Now, what we're seeing often is customers believe we know better than the manufacturer. And then they're very surprised when these membranes or assets last, instead of, let's say, a normal lifetime of 10 years or 25 years or 50 years, they only last 5 years. And everybody's surprised that after 5 years, I have to replace something which is very expensive. And now when you start translating this into the world of PDM, you can say, look, you're running it in this mode. That's a very bad idea. What is a better way of operating so that I get at least my 10 years or my 25 or my 50 years out of it? Because otherwise, I have to replace something way earlier, which means I need to come up with $50 million to buy this new kit. Otherwise, I have not the ability to produce, and especially in the world of desalination, when everybody needs water, these plants produce 1 million cubic meters of water every day. If you cannot produce 1 million cubic meters, only 750,000, it has a severe impact on people's life. And so that's why this CapEx protection thought becomes more and more important. They don't want to replace these kits too early. Ideally, they want to run them not just 10 years, they want to run them 15 years, because that means I can replace it 5 years later, which means I can save I can get at least a lot of interest instead of this amount. So this is a very big new challenge just not purely about failures. It's about, okay, all the commercial aspects into the equation, how this can affect a company. If you think about a nuclear power plant has to replace its turbine and generator, this is not something which you do quickly. It takes usually 3 years to do it, and it comes with substantial amounts of downtime in every year to make it happen. So if I can do this instead of every 25 years, every 50 years, you make these guys extremely happy because they have a significantly more amount of money in their pocket, and they have more money for OPEX, which is important because you want to keep these stuff safe and you don't want to waste your money with CapEx.
Well, from a person that worked on the front line at Goodyear facility, we had the latest technology. It was a flagship, keeping those machines up, utilized running. The idea of, taking one down and having to replace it, the impact on the production flow for us on the floor, outside of everything else, was pretty impactful. So that's very good to hear how that's all being integrated. So I'd like to move the discussion to our final topic, which is user-centric approach in IoT and future trends. So when I think of user-centric, I come back to the example I just shared, being on the factory floor, because that's where most of my time was spent with Goodyear. And so, Vinyak, what are some of the ways that we can channel and deliver AI-based visually for the frontline workers?
Yeah, that is very important, rather, because we have talked about the predictivity of the maintenance. We have talked about the preventive insights of the maintenance. But the question remains unanswered, like how these insights can be made available on the shop floor. Because all these analytics, if you do it on the computer table, and if they're not reaching in time to the workers, then there could be a probability of failures again. And there is no way to correct the failures. So it's always better to give that guidance at the runtime level. And that is where currently we are working, with the help of light, sound, and the projections. How exactly we can create the guided insights to give the workers at the runtime level, so they can get the complete guidance, which are the AI insights, like if they are doing something wrong with the machines, or if the machine is misbehaving, or any of the process is going wrong. So all the AI insights currently we are trying to get into the mixed reality, including the VR glasses, so that worker can implement those insights in their runtime level operations. And that is where basically I think the future trend would be, how the AI insights can bring to the human level day-to-day operations. And we are calling it as a theory of machine, methods, and the mind. So how all these three things can bring together so that workers can use them while doing the operations on the machine. And that would be the future trend.
Great, thank you. So let's talk a little bit about future capabilities. And so Jürgen, we talked about predictive maintenance contributing to CapEx, but can predictive maintenance contribute to the development of components or operational processes?
So the simple answer is absolutely yes. Because when we are looking what happens or what the outputs are of predictive maintenance solutions, it's not only guiding us to actions, it also should always guide us to rethinking of design. And when we have done in life science a great piece of work in both areas of components and processes. So you need to think about, as Jim earlier said, a lot of failures are sporadic or surprising. But if you see that this sporadic failure somehow comes again and again, it becomes to a systemic failure. And if it's a systemic failure, you need to find out where's it coming from and how do I fix it. So obviously you can say if it's systemic, my standard operating procedures are not working. So how do I come up with something new which is work and it stops to having this failure? So it means it gives you first the indications. You see, okay, it's a systemic failure. The failure is driven off that. It's a process, so it's not a direct equipment reliability issue. It is because you're doing something systemically wrong, and you need to get rid of that. Because otherwise, you can just throw a pump after a pump after a pump, and it will always fail in a very short time. So that's clearly indicates you it's not the equipment, it is how you do it. So you need to stop what you do. So, and hereby you can use then generative AI to say, based on industry best practices, this is how the new process is going to look like, and this will help you to get rid of this consistent breakdowns. Similarly, now when you shift to components, and you say, okay, I need a specific asset to do something in my process, people usually decide things based on their, let's say, experience. They say, oh, in the last 10 years, we always have used this component from this supplier, and it has generally worked. And it's a term, it has generally worked. If you look a little bit more under the hood, you say actually it has created lots of losses and downtimes and non-productive times, how you may want to call it. So you say, okay, is there a better component? You can say that is a better component in existence, or do we need to design a new better component? This brings you back then heavily in what Jim and Aviva are doing on the engineering side of things, of how you combine process data, predictive maintenance data, to create the requirements in the first instance for the new component, and say, okay, this is what the new component needs to do. Can we come up with a new specification with new, better computational fluid dynamics, new, better, like Alex said earlier, better energy consumption, that it doesn't get too hot, and all of that. So it brings you way more now in the world of generative AI, where you say, look, we can benefit from the outputs Medium produces, and that helps us then either design a new process to get just a simple process changes, get things running smoother, or if we have to go one step further, we have to design new components. Let it be we're changing material science, going to new materials, or we're changing the basic computational fluid dynamics to make things work. But there's a huge connection now coming between operational world into the design world, and how to use the two worlds to literally lift up your operation in terms of reliability, but also in terms of throughput, quality, yield, energy consumption.
Okay, thank you for that. So we just have really just a couple minutes left. I have 2 more questions I'd like to get out, so we're going to have to really condense these down a little bit. But one of the questions from the audience is related to digital twin. And they had asked, in which industries have you implemented IoT accessible inside of digital twin? And we actually have, as our next question, a question on that, which is for Vinya. What are your thoughts on AI-based digital twins, and how do you feel they'll fare in the future? And I'm going to have to ask you to try to get this down to just a minute and a half.
Yeah, sure. So it's a great question, because at the end of the day, all the benefits of the AI should be delivered to the end beneficiary, which is nothing but the people who are working on the shop floor. Digital twin always create the wow factor at the beginning to create the virtual representation of the machine and then apply the AI insights on it. But at the end of the day, if you ask the question, you got to see the machines in the 3D format, but what's next? So in my opinion, the next trend, and in fact, we have implemented the similar scenario, like how we can bring the digital twin on the shop floor. And I'm calling it like, rather than calling it as a digital twin, I think the right name is a real twin. And in real twin, basically, we can use the multiple technologies to bring those insights, whether it is a VR glasses or whether it is the lights and the projections. In fact, on the shop floor, nobody has a time to look at the tabular data or the graphical data, because operations are so fast. So if we look back, the Andon technology, which is 100 years old, people still prefer to get the insights in that format. And that is where basically the digital twin is heading towards, rather than to bring it out from the computer screen in a 3D format and make it as a part of their holographic body or even the projected body. We have reached up to the projection level digital twin so far in our current engagements. But yeah, I'm able to visualize, like, eventually the digital twin will wear the avatar of holographic kind of environment where the insights can be given to the workers at the runtime level rather than making it as just predictive or preventive. Let it become the part of the day-to-day operations. That would be the future state of digital.
All right, thank you. So we're at our last discussion point before we take audience questions or more questions. So this topic brings us sort of back full circle to where we began the discussion 40-ish minutes ago, which is sensors and data. So Alex is going to take us through a few slides as he explains how analog neuromorphic hardware can support the process of the raw data tsunami created because of the exponential use of sensors. He'll also share a couple use cases for predictive maintenance in IIoT. And again, Alex, we're starting to run short of time to get to our questions, so the floor is yours.
Yeah, I try to do shortness. I'm already explained why it's important to extract data on sensor level. And now in conventional way, we use various digital systems for this, DSP, ADC, and all of that is a step-by-step calculation. So all our digital system based on cycle. The biological system use through analog data processing, our brain, nerves, all it's through parallel data processing. And our approach to use this schematic for new category of equipment, it's new semiconductor device, analog neuromorphic core, which consists analog neurons working in real analog signals directly from sensor. And if you switch next slide, yeah, can you shift to next? The idea is split neural net model training, which now we did in digital environment, and we use the same Keras, TensorFlow, any type of environment. And our idea is convert this model when it's done, trained, and you have a digital twin or relevant model for your system, which is required. Then we can convert this model to NASP, neuromorphic analog signal processor, so new core, which 100 times more efficient than digital. Ultra low power typically work on microwatt level power consumption. And that is efficient solution to use existing competence, existing model development expertise, and then convert to a new chip category. And a few examples how that can be used for predictive maintenance area. Now we have very successful cooperation in tire industry, where decades was development concept of smart tires, which can detect surface condition, tire conditions, tire structure, frictions, and many important parameters. But all of this stuck for power consumption. So you need few years lifetime from one battery, and if you implement digital MCU inside the tire, it's drain battery for a few weeks. And here, a very good example, we implement this concept. So we build digital model, neural net model, which can detect surface condition, tire structure problem, etc., and implement this model to analog neuromorphic chip with few microwatt power consumption, and now full speed ahead go to deploy this technology in real products. So it's inside the commercial tire. Next big thing is vibration monitoring. Again, it's a very, very well-known technique for PDM industry, but again, always stuck for a wireless sensor and data transfer. If we use our technology, we can shift vibration signal pre-processing directly on sensor and drop from gigabytes to few kilobytes data transfer. So it's much cheaper, less battery power, so longer lifetime, and open many industries like fleet management. You can implement predictive maintenance to commercial trucks, for example, which today don't exist because it's too expensive. And of course, asset management. So the same concept. If you have more sensors, you can better predict your expensive asset status, and you can build upper level model of asset management.
Okay, great.
So
Alex, I'm going to have to jump in here because we only have 4 minutes left.
Yeah, I'm done.
Nope, we appreciate it. But I want to thank you. And Alex is providing, and it'll be added in the chat section, a link to his PowerPoint presentation. It's an extended version of it, so you can learn more about that. Now, I've just had a screen jump up. There we go. I'm back to you guys. Something popped up. So I have a question from the audience, and I want to say, Vinyak, thank you. I see that you're actually in the question and answer and actually answering some questions in there. So that's great. So one of the questions is, I've just slid it down. Let me find it. What are your thoughts about the platform having proprietary and standard sensors? Is a common set of sensors worth the cost and effort? Whoever would like to address that.
So let me get start with it. So I think proprietary or standard sensors is, I think it's not the real way we would say it. When you need to put the correct sensor at the correct location. I know that certain sensor companies out there, they just say you throw as many sensors as you can in it, and it's gonna fix your problem. What it actually would do is it would just create a data overload, and you get lots of nonsense data, which would just confuse your models. So the experience I have, and I'll be happy if others change, is it's often here less is more. So you need to do the right sensors at the right place, and it's often not some high complex. I know people see UT or TRT sensors for stuff like that. You can use very simple sensors around vibration, temperature, flows, stuff like that, which give you a wealth of insights what is happening, and then it's just smart augmentation of the basic sensor set at the right location to produce the insight you need. So this is what we see, and we get often the question where sensors are expensive, and customers are very concerned, will these additional sensors give me the additional value I want? And you will hear very often the answer is actually, you just spend money for nothing, because this data, you have it already, or you can easily infer it without big efforts of spending hundreds of thousands or millions in additional sensors.
Okay, I've got about a minute, not quite a minute left. So I'm going to throw this out, and you guys can just like shout out what you think the answer is. We don't need to get into too much detail. If starting your predictive maintenance journey, what would be your top 3 suggestions? Where do people begin?
I think from my side, very short answer. First, you need to define what result you expect. So what is your final spec for your PDM system?
Yeah.
You got 10 seconds.
So I think your data infrastructure is number one. You need a good data sensors and collecting the data. Number 2 is you need a solid goal. You need to know what you want to achieve. You want an outcome. Those are two of the 3 that are critical. And then you need to be able to put pragmatic software that's easy to deploy and roll out as the 3rd.
Okay, great. I'm going to end there because I got 20 seconds to get us closed. I want to extend a huge thank you to our panelists, to our session sponsors, Pollen Technologies, Harman Digital Transformation Solutions, and to each of you for joining us today. Thank you. Enjoy the rest of your event.
Thank you.
Thank you.
Thank you.
Thanks, everybody.
Thanks, guys.